Please welcome to the stage George Danezis with Exploring Decentralized Storage for Scalable Blockchain Application.
Great to be here, everyone. So I'm George Danezis. I'm one of the 5 co-founders of Mysten Labs. We're the people that initiated the Sui blockchain that some of you may have heard of. And Walrus basically is our new network that we're launching extremely soon. So we all have the experience of going on the web and looking for an article that we've seen a while ago that we liked, and the article is not there anymore, right? And sadly, this experience very often carries to the Web3 realm, right? Some of us had experiences buying an NFT. The NFT links to an address that is hosted on, let's say, some cloud, AWS, Google, whatever. It's there for a while, and then it's just gone. It disappears. Someone doesn't pay for the storage, and the NFT disappears. Even worse, we sometimes have the experiences of dApps just disappearing, right? I mean, we go to a dApp, we think we're having this kind of immutable, forever experience. We go again, the front end is not there. And actually, as of the recent few days, we even have the experience where we go to a dApp and we think it's there, but actually it's not the correct dApp, right? Someone has basically hacked the JavaScript, changed it with something else, and now we're basically signing the wrong transaction and sending a bunch of ETH to North Korea. That's no good, okay? So we all have these experiences, and what these experiences really tell us is that without actually having a usable on-chain data, not just smart contracts, not just what is in there, which is very little data, but actual data such as media, front ends, JavaScript, we can't really realize this on-chain future that we've all been talking about, okay? So this is where Walrus comes in, and Walrus is the second major network and protocol that Mysten Labs is launching. And basically the aim of Walrus is to put all of that data that is around smart contracts, be it media associated with smart contracts, audit logs, front ends, websites, and all of that, on-chain, on the Walrus basically chain, and give that data the same kind of guarantees we give to the data that is in the smart contracts and the integrity and the availability of smart contracts. And furthermore, we do this by leveraging Sui, the L1 that we build, in order to actually make that storage experience quite programmable, right? And I will want to talk a little bit about the programmability of Walrus as a decentralized storage network. So first of all, Walrus is a secure, decentralized blob store, right? What does that mean? It is a blob store in that it allows you to actually store media, images, videos, websites, the kind of stuff you would put on Amazon S3 or you would publish on the web. It is decentralized in that that data doesn't just live in a particular place that, can take it down and then the data disappears, but rather it lives on a decentralized network determined by delegated proof of stake of storage nodes. And it is secure in that it provides very high degrees of availability, very high degrees of integrity, and very high degrees of authenticity. So this is what Walrus is. And Walrus provides a programmable interface to this kind of decentralized secure store, in that all of the control layer of storage, namely the ability to pay for storage, get basically storage resources that act as something you own and you can trade and you can split like, a digital asset, the ability to upload files, control their retention policies, control basically the metadata associated with them, control when they delete, and all of that. This is all done on a smart contract platform, which means that you can basically interact with it through smart contracts and create very rich experiences, very rich and very high integrity experiences that combine storage and everything else that is happening on the smart contract platform. Names, DeFi, money, stables, etc., etc., etc. So Walrus allows us to do things like, we want to actually build a ticketing dApp. We keep a lot of the metadata on chain, such as the time, the place, how much it costs, etc. But then we keep the media of the ticket, let's say, on Walrus. And in fact, Walrus will provide in the future some confidentiality options, which means that basically we can, let's say, hide half the ticket that is this QR code and only reveal it when the ticket is being redeemed. We all had this experience already here in having an online ticketing platform on a blockchain. You can basically implement that whole thing purely on-chain using Walrus combined with Sui. Now, let me tell you a little bit about Walrus as a storage layer under the hood, right? Because there are other decentralized storage layers, so what makes Walrus different? So, first of all, traditionally, decentralized storage relies on replication, right? You take a file that you want to store, and you just put that file in multiple places, and that guarantees that if one of these places kind of is still there tomorrow, the file is still available, okay? All that is good. The problem with that scheme is that replication is very expensive, right? If you take a file and you put it in 100 places, well, you have kind of wasted 100 times the storage that you originally had for the file, right? So we're not doing that. Instead, what we're using is erasure coding. And erasure coding is a mathematical technique that allows you to take a file, expand it to a factor of about 4 or 5, and then take chunks of that expanded file and put them everywhere in the network, literally on every single storage node in the network. And even though the actual amount of data you waste in order to store that file is only like 5 times more than the original file, rather than, let's say, 100, it is still stored in hundreds or thousands of places. And furthermore, we can tolerate about 1/3 to 2/3 of these nodes that store the little chunks disappearing and still be able to reconstruct the file. And furthermore, we can tolerate about 1/3 of them disappearing and still be able to actually reads and writes and all of that, right? So this is a much more efficient way of storing files in a decentralized network, while at the same time allowing very high assurance reads and very high availability reads. Now, there is another interesting aspect of storage networks, which are kind of different from L1s as well, which is that in L1s, the more nodes you add, right, the more miners you add, you don't automatically increase the capacity of the network because they all have to do the same job and replicate each other's job to get higher assurance on the computation. Storage networks are quite different. As I said, like the replication factor, how much data has to be stored in the network to actually secure a file, is only 5 times the original size, no matter how many machines there are in the network. Which suddenly means that the more machines you add to the network, the more peers, the more storage nodes you add, the more capacity you have to actually store files. So the capacity goes up as you add more and more resources. Furthermore, the capacity doesn't just go up in terms of storage, but it also goes up in terms of bandwidth that is available to actually serve writes and reads from the storage system, which is pretty cool. I've already mentioned that Walrus comes with a full smart contract capability integrated into it. The way we built Walrus is to use Sui, the blockchain, as a control layer. So all of the metadata operation of Walrus happen on Sui, and you can combine them with all the stuff that is happening on Sui, which is a full-fledged smart contract platform. And the actual data paths are done off-chain, off the Sui chain, on the Walrus storage nodes. That allows us to actually deal with masses and masses of data very, very efficiently and very cheaply. And finally, Walrus comes with a nice set of apps already. We already have Walrus sites that allow you to upload a bunch of resources and make them available to the web. You can just go to docs.walrus.site right now and actually see our docs that are hosted on Walrus. And very soon we're going to actually release Seal as well, which is a technique to actually do encryption in order to provide confidential storage of files in this decentralized store. It basically is based on identity-based encryption. You have key servers that listen to smart contracts and are controlled by smart contracts to do the access control, and you can encrypt under those keys and release keys according to policies defined by smart contracts. So it's very flexible. You can literally program access control using Seal and store data confidentially on Walrus using encryption. So what's the vision, right? The vision is that, look, you know, there are a lot of operations that we do in decentralized apps that require audit, right? You know, if you have a DAO, if you're creating a charity on chain, etc., it's not just enough to govern that thing to look at things on chain. You actually want to have very rich material about what happened, audit logs, reports, pictures, etc., right? So Walrus allows you to build this kind of hybrid, you know, hybrid dApps between, you know, some governance that is happening on chain and the actual rich data you need in order to back that governance. We also are looking forward to, you know, suddenly the decentralized web also becoming a social web. But social webs usually don't just require metadata that we can store online on chains, but also require media. You want to post pictures, you want to post videos, you want to actually post 3D stuff in your feed and share it with your friends. And suddenly Walrus combined with Sui allows you to build these social relationships where that data lives on Walrus. The metadata lives on Sui and basically it encodes all the logic of the social. And furthermore, you can actually have brands and all of that stuff kind of rewarding fans, let's say, that post about football matches on the blockchain that basically track the social. And we also are looking forward to, a decentralized science application. Suddenly, having Walrus available to store bigger data allows you to actually store your experimental protocols, your data sets that result from experiments, your papers, and then you can still basically combine these media with effectively processes that you define on chain for peer review, for funding, etc. So you can basically really have these hybrid applications that deal with both the traditional stuff we want to do with smart contracts, as well as the rich media that is guaranteed not to go away and to be actually correct. We are going to market with a number of partners. These are just 6. We have many more. So Ethereum is actually using Walrus for decentralized music distribution. One Championship is going to do it for loyalty programs and distribution of, kind of like fan fighting videos, which is what they do. Talos is using it to build AI agents and AI models that are stored on Walrus and are basically driven on chain. Tusky provides a clone of Dropbox that is also private and decentralized. Decrypt Media is the well-known, trade crypto media site, and they're backing up basically all their stories on Walrus to make sure they're available if their website goes down. And Arkham provides blockchain analytics that live on-chain on Walrus so that you can make sure that they're there and they're correct and they're indeed the ones that are published by them. As I said, we've been running a testnet since about May. Walrus is there for all blockchain ecosystem to use it, so you can put basically an Ethereum front end on it and access basically Ethereum contracts, etc. So we're trying to basically serve the whole crypto community here, not just the Sui community. And basically, we're going to go to mainnet in Q1, which basically means within a few weeks. And we would be very happy to have you try it on testnet and then build your projects on it after that. Thank you so much.